Okay, the law of sines. That's what we're talking about today. We're still trying to solve triangles, and in the first section, we were focusing on the right triangles, but now we can no longer assume that we have a right triangle. Okay, we're looking at everything else. So it says to solve an oblique triangle. If it's not right, it has to be oblique. Means to find the lengths of its sides and the measurements of its angles. Okay, so there are four cases to consider. I never really remembered these cases, but it may be helpful to you to kind of figure out which of the laws we need to use with the different cases. Okay, but anyway, these are the four cases. We could have one side and two angles. Okay, that's known as angle, side angle, or side angle, angle. Okay, if we have two angles, then it's easy for us to figure out the other angle, right? Because the sum of the angles in our triangle is 180 degrees. Okay, we could have two sides and the angle opposite one of them. This is side angle. And I do think with these first two cases, we're going to use the law of sines, but we'll see if that's true. Then we got two sides in the included angle. That's known as side angle side. And then finally, we have three sides, which is known as side, and that's definitely going to require that we first use the law of cosines, and then we can come back to the law of sines. All right, so what is the law of sines? It says for a triangle with sides A, B, and C, and opposite angles A, B, and C, capital A, B, and C respectively, we say that sine A over A is equal to sine B over B is equal to sine C over C. Okay, that's the law of sines. All right, and the reciprocals are true. So we could flip this thing and say A over sine A is equal to B over sine B is equal to C over sine C. All right, so pretty simple rule, pretty simple law. All right, so let's see if we can apply it. Solve the triangle. We've got A equals 50 degrees, C equals 20 degrees, A equals, side A is equal to 3. So I'm going to do, first thing I'm going to try to do is find C. Because I'm trying to find side C, it'll save me a step if I say C over sine C equals A over sine A versus writing it the way that I did above. Okay, if I wrote it, it's okay to write it the way that we had it above, but then our first step would be to take the reciprocal of both sides. All right, so we've got that. So we get C over sine 20 degrees is equal to 3 over sine 50 degrees. Okay, and then we have to solve from there. Okay, we're solving for C, so we get 3 sine 20 degrees over sine 50 degrees. Okay, and then we can plug that into our calculator to see what we get. Okay, 3 sine 20 divided by sine 50. I want to make sure we're in the right mode, degree mode. And I got 1.34, we'll say. Okay. Questions about that?
So, so you like took the reciprocals of both A and C, then
From this first step,
yeah.
I took the reciprocal of both sides. Yes. Okay. I just went on and wrote it that way and saved myself having to do that step. Okay. All right. So we have to find all unknown sides and all unknown angles. So we've got side C, We've got side A, we've got angle A, angle C. The next thing I want to find is angle B, which will be easy. B is going to equal 180 degrees minus A minus C. Okay, so we got 50, 180 minus 50 minus 20, or 180 minus 70 is 110 degrees. And then I need to find side B. So I'm going to say B over sine B is equal to A over sine A. As much as possible, we use the information that's given to avoid any round off error. Okay, so I went back to the information for A rather than using this rounded off value that we found for C. Okay, so I've got B over sine of 110 degrees equals 3 over sine 50. Okay, or B equals 3 times sine of 110 degrees over sine 50. At this point, I should expect that side B would be the largest, right? Why is that? Why would I expect that? Something I said, I know at least once or twice this semester. Okay, that kind of gets to it. The largest angle will always be opposite the largest side, right? So we can see right now angle B is the largest, so side B should be the largest. If for whatever reason it comes out that that's not the case, then there's no solution to this triangle, okay? It has to be that way, otherwise we can't close our triangle. All right, so when we do 3 sine 110 degrees divided by sine of 50 degrees, we get 3.68. Okay, 3.68. So that's it. Those are our answers. We found side B, side C, and angle B. Okay, those are our solutions.
I don't get how you do like the second step of these, like for example, like C of sine 50 degrees.
I just multiplied both sides by sine 20 degrees. And so when I did that, I got, of course, over here, if I multiply by sine of 20 degrees, they cancel out. And then over here, we get 3 sine 20 degrees over sine 50 degrees. All right, other questions? Okay. So I think this case we would call, if you want to keep up with that, side angle, as we had A, I guess that's what we would call it, side angle, angle. Was that the first case? Okay, side angle, angle. No, I don't memorize those. What I do is look at the information that's given and figure out which formula we need to use. Okay?
And
B equals
180 degrees minus A minus C. What part of the formula is that?
well, we know the sum of all the angles in any triangle is 180 degrees.
Okay.
So I could figure out what B was by subtracting off A and C.
Okay, I get it.
Okay? All right, let's look at another example. Okay, we got B equals 20 degrees, C equals 70 degrees, and A is equal to 1. So this is angle side angle. Somebody that's going to mean something to. So I'll try to note it a couple of times anyway. This side has to be between these two angles that it doesn't belong to because its angle is going to be opposite. So that's angle side angle. So the first thing I could do is what? Yeah, this one does turn out to be a right triangle. I hate that. I need to change that in the notes. But let's pretend as if it is not, because we want to demonstrate the law of sines. So how could I use the law of sines to solve this? Since I have side A, that's the only side I have, then I need what? Angle A, right? So angle A is equal to 180 degrees minus 20 degrees minus 70 degrees, or yes, it is indeed 90 degrees. Okay? So now that I have that, I can figure out side C and side B. We'll do B first. B over sine B is equal to A over sine A. Okay? Or B over sine 20 degrees is equal to 1 over sine 90 degrees. And of course, we know sine of 90 degrees is what? 1. Okay? All right, 1. So we get B is equal to 1 times sine 20 degrees. So on our calculator, just punch up sine of 20 degrees. So B equals 0.34. Okay? Questions about that? All right, and so we do the same thing for C. We say C over sine of 70 degrees is equal to A over sine A, which we already said was just equal to 1. So C over sine 70 degrees equals 1 over, what was A? Sine 90 degrees. So C equals sine 70 degrees. Well, these are just the first one. So 0.94. C equals 0.94. Okay. All right, and I think that's it. We got angle A, we have sides B and C. Okay, questions about that? Okay, very good. Now, this time we've got two sides, and we do have an opposite angle. This one is very different from the first and second examples in that in both A and B we had two angles, which is nice. It's really easy to find the third angle if you already have two of them. But in this example, we've got one angle, and they gave us two sides. So not impossible, just a little different. So I've got side B, angle B. So I'm going to start with sine C over C is equal to sine of 40 degrees over 4. Okay? And we need to solve for angle C. So this is, I could have gone on and put that over 3. Okay, sine C equals 3 times sine 40 degrees over 4. Okay? So how do I figure out what C is from here? Well, okay, we did that. Now what? How do we find out what C is from here? Nobody? We take the inverse, sine inverse, both sides. All right, we do sine inverse, both sides. That gets rid of sine over here. Does everybody understand that? Right? Well, this let me that's bad, bad, bad. Let me not write that. Where's my pen? Okay, sine inverse of this thing. So we're going to take sine inverse of both sides. Okay? All right. So over here, that leaves me with just C, and then we do sine inverse. Remember, the output of the inverse function is what? Angle. Very good. So out of this, I get an angle, and that's what I'm looking for. Okay, sine inverse 3 times sine of 40 degrees divided by 4. We get 28.8 degrees. Okay, questions about that? On the calculator, I just hit second and the sine key to get to sine inverse. Okay, on. Make sure I'm in degree mode. Come on. Okay. So I do second sine, which gives me the sine inverse, and then what was it? 3 times sine 40 degrees divided by 4. Okay, so we got 28.8 degrees. Okay. And here's where it gets interesting. Remember, sine inverse is only going to give me one answer, right? It has to do that so that the inverse function is a function. However, we know whatever this number is, there are two places around the unit circle where sine c is equal to whatever this number is, right? So where's the other place, and is it a feasible option also for an angle? So here's angle C. This is over here, 28.8 degrees. Okay, but sine is positive over here too, right? So there's an angle in this second quadrant such that sine of whatever this angle is equal to this number. Okay, so what is that angle? Well, it's going to be 180 degrees minus 28.8 degrees. Okay, so let's look at that one. 180. There, what I'm telling you is there can be more than one triangle. We can have one, we can have two. It's possible that we can have 0. So we got to check all of the possibilities. So 180 minus that angle we just found gives us 151.18, we'll say. So I'm going to call that C prime equals 151 point, what did I say, 18? I think 18 degrees. All right, but is that a feasible solution at this point? No, it's not, okay? Does everybody see that this is not feasible? It's not feasible because if I add 40 degrees to it, that's more than 180 degrees. So I don't have to go any farther with this solution. That won't work. But sometimes it will, because between the first and second quadrants, we just have 180 degrees. So it's possible that we can have solutions in both of these quadrants. Okay, so not going to follow that path anymore. We've got angle C. Okay, we've got side B, angle B. So let's find what? What can we find next? Let's find angle A. It's 180 degrees minus 40 degrees minus 28.8, I'm going to put dot, 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 degrees, okay, because we want to use all the bits and pieces. We don't want to have too much round off error. So I should have saved that on my calculator, but that's okay. Let's do it like this. 180 minus 180 minus second answer. Okay, I'm just going to go on and store this. We'll use storage a lot here as alpha C. I think it was angle C, so I got it now. So I want to do 180 minus, was it 40 degrees? Okay, and then minus alpha C. And so we get A is 111.18, which was not that same thing, so that's fine. Okay, 111.8 degrees. All right. Although, again, when I use this in my calculation, I'm going to use all the bits and pieces. Is that what you all got? It's what? 0.18. Okay. All right, very good. Okay, so now we can say what? A over sine A is equal to B. I'll just go ahead and write it as 4 over sine 40 degrees. Okay. Or A equals 4 times sine of 111.18 dot, dot, dot over sine 40 degrees. Okay. All right, so we get 4 sine of that previous answer, okay, divided by sine 40. I got 5.8. Is that what you all got? Okay. So let's look at this. Okay, this is a length, right? So we got a side of 5.8 opposite this largest angle. Is that going to work? No, it won't, right? I mean, imagine, let's say what I'm holding here would be the sides, two sides of a triangle, right? And where my arms, I guess, kind of converge would be the angle. The larger I make that angle, the larger that opposite side has to be. Can you see that? So it's not possible for us to have, or is that our largest side? Oh, well, actually, I'm sorry. I got ahead of myself. That is the largest side, so it's okay. All right, we had a side of 4, we had a side of 3, and then this one is 5.8. So there we go. So that's our solution. A is 5.8. Angle A is 111.18 degrees, and here's our angle C. Questions about it? Okay. All right, very good. Okay, why don't you try B on your own? Okay, all right, let's see. All right, so I'm doing sine B over 7 equals sine A. I'm not sure what angle A is, but over 3. What's that? Oh, right, okay, 70 degrees, thank you. All right, I don't know what angle B is, okay? So we've got sine B is equal to 7 times sine of 70 degrees over 3. So we get sine inverse. We're not there yet. I think we're going to get there. Um, but not, yeah. I don't need to do sine inverse yet. I mean, that'll be my very next step. Okay, well, yeah, okay, we can do that. I mean, we don't have to evaluate this thing out. So B equals sine inverse. I was going to find the number, but it really doesn't matter. However, sometimes it's useful for us to do this because let's find the number. Let's say the number comes up to be something outside of -1 and +1. Then we know right there that we can't go any farther. Okay, that's why. So let's just right. I mean, so let's do it. Remember the range of the sine function is -1 to 1. So if this number is outside of that range, that's not possible. So okay, what was I doing? Did I get it? No. 7 times sine of 70 degrees divided by 3 is 2.19. That's not possible, right? So B equals 2.19, or rather sine B equals 2.19, not possible. So we say there's no solution. Questions about that?
So in the test, if we run into that, it's just no solution.
Right, no solution. That's it. All right. Okay. Yes.
Uh, so when do you determine that you don't do the inverse or something?
Well,
You said graders.
right. So, when we went on and evaluated this piece, it came up to be 2.19. And sine has a range from -1 to 1. So there is no angle for which sine of that angle would be equal to 2.19. So we say no solution.
So when would you use sine inverse?
Well, if we'd come up with a reasonable number, we would, do sine inverse. Let me go back here. On this one, I could have said sine C. Let's see if I can move this down a little bit. So I can capture this. I could have said, oops, left the circle. Okay, there we go. I could have said sine C is equal to, and then on the calculator we could have done 3 times sine of 40 degrees divided by 4. So we get 0.482. Then we would say C equals sine inverse of 0.482. Okay, that's basically what we did. We just didn't find that this piece was equal to 0.482. That's all. My coffee is really working today, so I skipped that step. I'm sorry. Okay, so yeah, C equals sine inverse of 0.482. 0.482 is between -1 and 1, so that worked out fine. Yes.
Is there a way to determine that without putting it in the calculator first?
Which piece?
Like determine that 3 sine 40 degrees over 4 is lower than 1 on negative 1 to 1.
Um,
Yeah.
maybe. I mean, but I mean, we could say, okay, sine 40 degrees. If we wanted to estimate, we might say it's about what? Uh, root 2 over 2. And then we'd have to say 3/4 times root 2 over 2. I mean, it'd be an estimate. It'd be easier just to put it in the calculator, I think. All right. Other questions? Okay, very good. All right, so we're clear. We had to use sine inverse. Whether or not we evaluated that piece that we were plugging into the inverse function first, or we just plugged the whole thing in, didn't really matter. If we evaluate it first, then it could alert us to an error, that there would be no solution. Okay. All right, very good. So let's look at a little word problem here. At exactly the same time, Tom and Alice measured the angle of elevation to the moon while standing exactly 300 kilometers apart. The angle of elevation to the moon for Alice was 49.9312 degrees. The angle of elevation to the moon for Tom was 49.8974 degrees. To the nearest 1,000 kilometers, how far was the moon from the Earth when the measurement was obtained? Okay. All right. So when I look at this picture, what do we note? What do we have? What kind of information do we have? Okay, we got two angles and a side. Okay, one of those angles is not in the triangle. This one is not in the triangle, but I can figure out what this angle is in the triangle by doing what? Subtracting from 180. Okay, so this other angle on the inside is 180 degrees minus 49.9312. So we get 130.0688. Okay. Okay, degrees. Okay. So I've got angle, side angle. Okay, we're trying to find the distance to the moon. It's going to be an estimate. They're really not, in the large scheme of things, that far apart. So it really doesn't matter whether we find Tom's distance or Alice's distance. Doesn't matter. Okay. It's going to be to the nearest 1,000 kilometers, so it doesn't matter. Let's call this, if that's the moon, I'll call this side M. If this is where Alice is, I'll call this side A. And if this is where Tom is, I'm going to call this side T. Okay? Let's find side A. All right? So we get A over what? What is A going to be over? Sine, what's the measure? 130.0688 degrees. Okay? Is equal to, we need to find one more thing. What else do we need to find so that we can solve this? Okay, what do you think I was going to set it equal to? I got a side over sine of an angle is equal to what? What were we going to put on the top over here? Well, except we don't. Well, I guess we could do that. Can we do that? We don't know. We don't know T. That's what we need to do, right? We've got this side 300 kilometers, so we need to know this other angle. So it's going to be 300 over what's the moon angle? Very good. Okay, we needed to figure out what angle M was, right? Okay, so it's 180 minus that 130 minus 49.987. Oh, what happened there? La, la, la. 300 over. Right, that second 49 is on the outside of the triangle. We got 49. We've got okay, let's see. We might need that. That might make the difference. Second enter. Oh, now I gotta do the whole thing. Okay, 180 minus 49.8974 minus 130.0688. Okay, 0.0338. So we were both slightly dyslexic. 0.0338 degrees. Okay, so we're going to say sine of 0.0338 degrees. Okay, so we get A equals 300 times sine of 130.0688 degrees over sine of 0.0338 degrees. Okay, questions about that before we put it into our calculator? Okay, so we get 300 times sine 130.0688. What? Well, we're talking about a long distance, right? To the moon, very long. Okay, divided by sine of 0.0338. Oh, I don't have an O. So yes, and then they said round to the nearest thousands. So we would say, what, 390,000 miles? Okay. Is that what we were looking for? Yes. Okay, A is approximately 390,000. Actually, this was kilometers. So roughly, I think, about half as many miles. Okay. I think a mile is about 2.5 kilometers, something like that. Okay, questions about this? Okay. All right, very good. All right, we could Google it and find out the distance from the Earth to the moon to kind of see if we're right. Of course, that's something that changes depending on, where we are, what's going on in the atmosphere, or whatever. All right, here's another example. I like this one. We've got a loading ramp 10 feet long that makes an angle of 18 degrees with the horizontal is to be replaced by one that makes an angle of 12 degrees with the horizontal. Why would we want to do that? What's that? It wouldn't be as steep, right? But the trade-off is it's going to be what? Longer. It's going to have to be longer. Okay, it's not as steep, but then it's going to take us longer to get up to the dock. Okay, so how long is the new ramp? So let's make a little picture. Let's say this is the dock. Okay, we had a ramp that was 10 feet. So let's say this is 10 feet. And it made an angle of 18 degrees. Okay, well, we're tired. We don't want to have to walk the steep ramp. So we decide to lessen the steepness. But now it's a longer trip up. Okay, now we have an angle of elevation of 12 degrees. Okay. And we want to know what this distance is. I'm going to call it N for new ramp. Okay, is that an accurate picture? All right. So what do we have here? And how are we going to answer the question? Okay. All right, that's nice. Okay, we got a right angle over here. Okay. So we do have So we've got a right angle, we've got another angle, so we can figure out all of the angles in each of the two right triangles. I don't know if that's really going to help us. What else do we know? Well, maybe. What could we do with that right triangle that could help us a little bit?
Opposite side of n, 12, because that's going to follow this diagonal.
Say that again.
Like, if you find n,
Well, n is what we
the
ultimately want to know.
opposite side of n, the n,
Okay, so I mean, there's a lot of stuff up here.
yeah, up there, but
This one?
is the red triangle still in the 90 angle there?
Well,
Yeah,
if you do all of this,
yeah. So
that's
that,
still 90.
yeah, so that's going to be the opposite of n.
The right angle and the length of the hypotenuse of the first ramp, you can
Yeah.
potentially find the height of where the ramp meets the wall.
Okay, all right, that's the way we could do it. So you want to find this. You want to find the height of the ramp. Okay, all right, so we're going to go all the way back to right triangles. I got that. Okay, we could do that.
How would you do it?
Well, I'm thinking one, I can figure out this angle, right? So that would be 180 minus 18, so that's what, 162? 162 degrees. And this angle is opposite this side. Um, and actually, you know what? I made an error on my diagram. We don't really know. This is not the length of the ramp. The length of the ramp is right here, right? The new ramp. Okay, I made an error there. Does everybody see that? This would be the length of the ramp. New ramp. So I've got the angle opposite this thing that I'm trying to find, and I also have a pair, an angle and the opposite side. So whenever I've got, that pair, given one of them being unknown, I can use the law of sines. Does everybody see that? So what I could do is, I may have misled you, I'm sorry, but we could say n over what? Sine of 162 degrees, right, is equal to 10 over sine of 12 degrees. Does that make sense?
It's sort of hard seeing that's 12 degrees. That's opposite of 10 feet there.
Okay. Well, it has to be. Let's kind of clear up the triangle that we're looking at. We're looking at this triangle.
Okay.
Okay. So then their 12 would be opposite the side that's 10 feet.
Okay.
Okay. All right. So then in that case, we get n equals 10 sine of 162 degrees over sine of 12 degrees. Okay. And so we can divide or simplify the right side there. That was 10 sine of 162 divided by sine 12. We get 14.86 feet. Okay, that's the length of the new ramp. So 4 feet more. Just maybe a couple of steps. All right, questions about that? Okay, very good. All right. And that might have been the last one. Yes, that was.